Problem number 2771, longest non-decreasing subarray from two arrays. You are given two zero-index integer arrays nums1 and nums2 of length n. Okay, so two of the array has the same length. Let's define another zero-index integer array nums3 of length n as well. For each index I in the range 0 to n minus 1, you can assign either nums1i or nums2i to nums3i. Your task is to maximize the length of the longest non-decreasing subarray in num3 by choosing its values optimally. Return an integer representing the length of the longest non-decreasing subarray in num3. Okay, a subarray is a contiguous non-empty subsequence of elements within an array. Longest non-decreasing subarray. Okay, so let's first check the limitations and the boundaries of the problem. So for num3, the maximum length will be n, and the minimum will be 1. If both of the, like, if nums1 and nums2 has at least one element. Okay, yeah. And for the element inside each array, it is all positive integers, which is larger than 1, larger or equal to 1. Okay, so like we can have this like nums1 equal to 1 and nums2 nums2 equals to 2. 2 maybe. Oh, but like the range should be, yeah, so if you pick like if for num3, if you pick 1, then you cannot pick 2 since it has the same integer. So okay, so for each num3 element, there is 2 options. Yeah, you can choose from, I would say nums. Let's do it. Nums1 equals to 2, 3, 1, and for nums2 it is 1, 2, 1. So for nums3, so you can choose, like, so for this it's definitely 1. Yeah, you can choose between these two, and for this you can choose between these two. Maybe maybe we can have 2. Oh, but then it will not be increasing. But well, then for this we can have 1. So we have an increasing subarray that is 2. Oh, it says non-decreasing, so 2, 2 can be also an option. Okay, so I am guessing we want to have we want to have the longest non-decreasing subarray. So I'm thinking, okay, so for having longest non-decreasing subarray, that it means like when you are at nums I, there will be an option that like for subarrays that ends at nums I, like you can take the previous length from you can take previous length like from the maximum length from nums I minus 1 plus if the previous element is smaller than the current value, then you can add it by 1. Else, you will have to start by yourself. Okay, so okay, and there are two options, like if select from like if okay, I think it will be longest the longest non-decreasing subarray ending at nums I will be equal to the length from nums I minus 1 or 1, and that is start by itself. Okay, so and for so there are two options for the previous length. One is from nums 2 and one is from nums 1. yeah, there's just like I am thinking of a greedy option. Like if I try to choose like the smallest, if I if I try to choose the smallest one, then I can get not sure. Yeah, like maybe this is 2 2. Sorry, maybe 4 4. Then there is like a 2, but no, yeah, smaller will be better. Okay, let's first stick with this DP solution, since it is like repeating the same problem. Like the current like if the subarray ends at the current value, the longest subarray will be equal to the length from the previous subarray that ends at nums I minus 1, or it can start by itself and then it's 1. So yeah, since it is a dynamic programming solution, I would like to first use recursion, and I'll name it. I will use a depth first search and name the function as DFS. So for DFS, I will first have I, and so yeah, I think the definition will be this: the longest non-decreasing subarray ending at nums I and DFS I will be equal to DFS I minus 1 like x plus 1, or I'll say plus 1 if nums I is smaller is larger than nums I minus 1. Or it can start by itself 1. Okay. Yeah, now let's deal with like which array to select. Okay, so okay, so for this nums I minus 1, there are 2 options. Oh, and this nums I has 2 options as well. Okay, so I need to have another parameter to keep track of the current array, which it is where is it? I will say let's say A, so 1 and 2, array 1 and 2. So for A, okay, so if nums so for A, that means nums I is coming from A array. Okay, and for A it has like 1 and 2. So when A is 1, that means nums I is at the nums is from nums 1, and so if nums 1 I is larger than nums 1 I minus 1, then we can for nums 1, or we can have nums 2 here, nums 2, or we can start by ourselves, that is 1. And for if the current value is from nums 2, then similar. So for nums 2, it is larger than nums 1, it is nums 1. Yeah. And for nums 2, if it is larger than nums 2, then we'll use nums 2. Okay. And at the end we have to for each nums I, we have to check each of their lengths and see which has the maximum. Okay, and the boundaries will be not boundaries, but the time complexity will be big O n, since A has only 2 options. Okay, and let's start with n equals length nums 1, and we'll have the function I and A. Let's talk about the boundaries later. And for other values that is not in the boundaries, if A is 0, we return, not 0, but 1. We return and I am not sure if I can write like this, like there is a condition here. Maybe I will add else and it will be 0. Okay, then yes. Return L0. Okay, and else if a is 2, then we will have this. Oh, we don't need this else clause. We will have return function directly, else 0, and here else 0. Okay, and let's have the boundaries. So I don't want I minus 1 to be out of bound, so if I is smaller than 0, it should return 0. Or I think, yeah, like this is 0, or no, if I is 1 and this is 0, then yeah, I think it should be I. Yeah, since we will have this condition first, then went into and dive into the DFS recursion. So I think we will have, if I is 0, then that's return nums, no nums I, but okay. If a is 1, return nums 1I, or then return nums 2I. Then now, yeah, I think we have to loop through, like, yeah, it's kind of a huge thing. Return maximum for okay, for I in range n, and this will be maximum between DFS I with 1 and DFS I with 2. Okay. Oh. Seems like I added 1. Like I'm not sure why. Yeah, maybe let's first see the first example, like try run the whole thing. Okay, so for okay, let's first try this. When n is 1, I is 0, 0, 0, yeah, I think for this it will be correct. It says return the length, but you should return 1. yeah, then you may have like this and 0. Okay. Well, good. Then we will change this to for loops. So first of all, we will have a matrix, and that will be the size of there will be n columns. We'll have n plus 1 columns, since we will have a dummy node for this I smaller than 0. So and the columns will have 2 columns, since A only has 2 situations. So let's name it max length equals 0 multiplied by 2, and for in range and plus 1. For I in range and for max then I plus 1, since we have a dummy node, and when A is 1, so now A should be 0. Okay, when A is 0, then it will be maximum between max then I with 0 plus 1 if nums 1I. Yeah, like the current value is larger than the rest of it. The previous subarray, like the previous the previous value. And since this is indicating, like the previous value, the previous subarray is from nums 1, then we should compare this value with nums 1. Okay, and else it will be 0, and or if the previous subarray comes from nums 2, not DFS, but makes sense. So this is I minus 1, and we'll have 1. It will plus 1 if nums 1I is larger than nums 2I, else 0, and it can start by itself. Okay. And we can copy this, change it to another situation if we are now finding value from nums 2. Then the current value is nums 2, current value nums 2, 2. And if the previous value is from nums 1, okay, so nums 1 here. The previous value from nums 2 here. Okay. Okay. And we can return like the whole thing has to do let's have answer here. We'll have 0 first, and we will compare the answer at every iteration. Did I have something wrong? No. it's terminal 0 started. This is from nums 1. Oh, I think this is no. Makes then I0, it's correct. Oh no. Oh, I think this will be out of range. Yeah, this will be out of range, and this should be I minus 1. I think we will start from 1 and yeah, and for the first two values we will have 1. So for 0 row it will be 1. And for here we will start it from 1, so it will not be out of bound, and this we should change back to I. This is I minus 1. I minus 1. This will be, oh, this is this should be I. This is I minus 1 plus 1. I minus 1. Okay. Let's see. Okay, good. Oh, this should be, oh, bad. Yeah, this should be at least 1. Yeah, it's like, yeah, since nums 1 and nums 2, the smaller size of its array is 1, so there will be at least 1 decreasing subarray. Okay, then we can still optimize the space to like constant or 1 space, since this like the answer only depends on the previous row. So yeah, we can change it to like mx then 1 equals 1, and mx then 2 equals 1. Okay, and we can change all this 0 thing to next time 1, and 1 be max times 2. could do it in a line, since if we don't do it, the value will be covered. I want to do maybe like this. Hope it can work, and we can delete these two lines. Okay. Okay, done.